Hi guys, Vicky the Science Tutor here, and today we're going to jump into the fascinating world of ionic bonding. So if you've ever wondered how something as simple as table salt holds it all together, or why opposites really do attract, that is ionic bonding in action. Okay, so if you're ready to unravel the science, let's dive in. Okay, so the first thing that is going to help us with ionic bonding is to understand where the division for metals and non-metals is on our periodic table. And this is something that I go on about a lot, is understanding those basics. Understanding what the periodic table can tell us straight away, so that when we come across something such as bonding, if it is a question that is an unfamiliar context, you haven't heard of that substance before, we can have a look on our periodic table, decide what type of elements they're made up of. Is it metals and non-metals? Is it two non-metals? And already by knowing what it's made up of and knowing the type of bonding that occurs, we can start to understand the properties, what's going to happen in terms of electrons, etc. So in this session and the next couple of sessions on bonding, I'm also going to give you the sort of rules to understand how do we know what type of bonding is going to occur, because once we lock in those rules, if we're given something that we haven't heard of or seen before, we can start to unpick them. Okay, so the way to remember where is that division of metals and non-metals, I remember this as the aluminium steps. So we come across the top of aluminium and we simply step our way down the table. Okay. So the majority of the table is made up of metals, and it's only this small top right hand side section that are the non-metals. And this is going to help us because when we look at ionic bonding occurs between a metal and a non-metal atom. So by knowing where that division is and then simply locating where our elements are, we can work out what type of bonding is occurring. Okay, so let's jump into the rules of this. Like I say, once you've locked in those rules, you can then unpick any out of context example that crops up, even if it's something you've never heard of before. I'm going to use sodium chloride as our example today. That is common table salt. We've probably all heard of salt. But if it was something that was different and you hadn't heard of it, we can still apply these rules and work out what is going to happen. Okay, so ionic bonding is a transfer of electrons. So electrons move from one atom to another. And the rules is that the metal atom always loses electrons. Okay, metals always lose electrons, and the non-metal atom gains electrons. Now I suppose I should put electron and an S in brackets. I'll do the same for that one because it might be one electron, it might be two electrons, it's dependent where they are in the table. So just while I'm thinking about that as well, we also know by looking at this, so we can see, so our example, let's base it around that. Our example today is sodium chloride, so here's sodium and here's chlorine. So what we can do straight away is say, okay, well sodium's going to lose the electrons and chlorine's going to gain them. And we want to think about, well, how many electrons are they going to lose or gain? So remember, this group number also tells us the electrons in the outside shell. Okay, so we can look and think sodium has one electron in its outside shell, and we know it's going to lose that. Chlorine has got 7 in its outside shell. It's a non-metal, so it will gain. So the electron transfers from that metal atom over to the non-metal, producing us ions. Okay, and I'll talk about those terms in a second. So following that transfer then, the metal atom becomes a positive ion. And we need to be careful with those terms. Before that electron has moved, we refer to it as an atom, because atoms have no overall charge. They have the same number of protons and electrons. When that electron is transferred, it now means that that sodium has more protons than electrons, because one has moved across, and so we get an overall positive charge. And dependent on how many electrons move, that will impact the charge. So our sodium is just going to lose one. But if we think about magnesium, that is in group 2, 2 electrons in the outer shell, therefore 2 electrons are going to transfer, and that will give it a positive 2 charge. So an atom is when we've got no overall charge, and an ion is referring to a charged particle. So once that transfer has happened, we then call them ions rather than atoms. Okay? And so on the opposite of that, our non-metal will become a negative ion. And that becomes negative because it's now gained an electron. It's now got more negative electrons than it has positive protons, and therefore overall it has a negative charge. Oops, I was going to write charge because that's what I was saying. The word I actually want is ion. Okay, so those are the rules of ionic bonding. Whatever combination is thrown at you, whether it's something out of group 1, group 2, group 6, group 7, whether it's gaining 1 electron, 2 electrons, whatever, these are the same rules. We know that the metal will always lose the electron. And when I show you some exam questions in a short while, we'll see that some of the harder ones will use something a little bit more unfamiliar, so bringing it into remember that unfamiliar context, and it might give you calcium that has 2 electrons in its outside shell, and it might give you fluorine that's got 7. So if calcium's got 2 electrons in the outside shell, we're going to need 2 fluorine atoms to each gain one of those electrons that are being lost. But we'll see that in some of the examples that we look at in a little while. Okay. So in terms of exam questions for these, I love these questions because once you lock in these rules, these questions are usually worth 3 to 4 marks, which is a hefty chunk of marks. And if we just follow this same thought process and this same pattern, it's really easy to pick up those marks. Okay, so I'm going to show you how to structure those answers in a short while, but one thing I'm just going to touch on very, very briefly is these ionic formula, because the harder level questions might give you the ionic structure and you've got to work out what it's done in terms of electrons. So this is aimed more at higher level students. Now what we can do is, if we think what we've just said earlier about that loss of electrons, so remember that group number tells us how many electrons are in the outer shell. We'll put on our aluminium steps again. Oops, it's a bit wobbly, but it's fine for the purpose of this. And if we then think group 1 has got 1 electron in its outside shell, we know the metals because they're on the left hand side of the table, and therefore anything in group 1 is always going to become a positive 1 charge because it's going to lose 1 electron and have 1 more proton. So they're always going to become +1. On the back of that then, that magnesium Well, yes, magnesium, that's because I've had that in my head as an example. Anything that is in group 2, including magnesium, will become a +2 ion. And then they usually pair up with group 6 and group 7. Group 6 have got 6 electrons, they can gain 2, and therefore they will always become -2 ions because they're gaining 2 negative electrons. And group 7 always become -1. So you might see something in the question. I'll just give you a couple of variations of things that you might see. If you saw that we had MgCl2, from that you can work out we've got 1 magnesium. Let's have a look, it's in group 2. So your magnesium is going to come 2+ ion. So we know that's going to lose 2 electrons. And our chlorine is in group 7. It's going to gain 1 electron, and that becomes a -1 ion. So in order for those to balance, we can see that actually we need 2 chlorines. So when we're telling the story in the exam questions of what happens, we would talk about 1 magnesium atom losing 2 electrons, and they transfer to 2 chlorine atoms. Okay, so we can work out what's moved where by simply looking at that formula, if we understand when we lose and gain electrons the charges they become. Okay, right, let's jump into some of these questions then. So as I was saying, absolutely love these, because when you get into your mind the order to go through it, and it gives you a diagram. You just have to literally say what you can see. Easy peasy, say what you can see. So this is a lower level question because we've got lots of information there. We've got a diagram there, it's got the electrons on, it's got the charges on, and this is worth 3 marks. Sometimes they're worth 4, and for the additional 4th mark there will usually be a separate little sentence underneath that says something along the lines of, to gain full marks you must use the word atom, electron and ion. So in my examples, although I don't need to do it for this one, I'm still going to set it out in a way where I use the words atom, ion and electron, because then I'm never going to forget to put them in and I'm always going to gain the marks. Okay, so I'm going to do this one nice and slowly, start to structure the sentences, show you where you're picking up that information from the diagram, and then we'll move it up a level into a mid-level question, still following the same pattern. Okay, so I'm going to start my story here. I'm going to talk about sodium first. I'm going to say a sodium atom, because it's an atom at the moment, it's not lost or gained any electrons yet, so it's still classed as an atom. And then we're going to have a look at what does it do. So here it's got 1 electron in the outside shell, and when we look over at this side, the electron has gone and it's now become positively charged. Okay, so I'm going to say a sodium atom loses 1 electron and becomes a positive ion. It's a good job we know what we're doing, isn't it? Alex can't help. Okay, now already in there I've gained 2 marks because I've identified that sodium loses electrons, I've identified that it is just 1 electron, and if that was a 4-mark question, I'm already on my way to gaining that 4th mark because I've already said the word atom, electron, ion. So essentially I've already scored 3 marks because I've put those in. And then we're going to see what we can see for sodium. And by sodium I mean chlorine. Get carried away with myself. So here look, we can see it's got 7 electrons. Over on this side you can see it's gained that electron, and that means it's become a negatively charged ion. So I'm just pretty much going to repeat what I said above. A chlorine atom gains 1 electron, and becomes a negative ion. How easy is that? The diagram's there for you. So even if you'd pretty much forgotten about ionic bonding, by using that diagram and say what you can see, I bet you could get 3 of those marks. Easy. Because you're just saying what's in the diagram. Okay? Let's take it up a level. So this is a sort of mid-level question. And this one is worth the 4 marks because that's that extra little sentence. To gain the 4 marks, use the words atom, ion and electron. But using the structure that we've just done, we're going to hit that marking point anyway. Okay, so again, we've got some information. We've got the diagram to help you with the question. As always, as I always say, if there's a diagram there, look at it, use it. It's giving you some clues. They're there for a reason. You don't just put them in to put in pretty pictures. They're there for a reason. They're there to help you. Okay, so I'm going to move through this one quite quickly because we're just going to simply follow the same pattern. Okay, if you're unsure what K is, we've got the word equation at the top, or you can look it up on your periodic table. So I'm going to say a potassium atom loses 1 electron and becomes,
I'm not quite sure how to help you with that.
I don't know why Alexa's trying to help us, and becomes a positive becomes a positive ion. That wouldn't impact my answer. I wouldn't lose any marks for that, but I would then I would run the risk of not saying the word ion. Okay, so already I've said atom, electron and ion in that. So all I'm going to do is just repeat that for what is happening to iodine. I think Alexa's thrown me, you know. They spelled incorrectly. So an iodine atom gains an electron and becomes a negative ion. How easy is that? Yeah, hopefully it's making it really nice and structured and straightforward and something that you can follow, pick up 3 to 4 marks, easy peasy. Right, let's have a look at the next one. Now this one it's another 4 marker because we've got that sentence there again to gain the 4 marks, etc. Now this one is slightly higher level because we've got our magnesium. So I give you the example of magnesium chloride. We've got the same idea. We've got something from group 2, therefore it's going to lose 2 electrons, and we've got 2 individual iodines that are going to pick up 1 electron each. So I'll do exactly the same with this. If you want to hit pause on the video, have a go at this one first, and then check back in and go through my answer. We're going to do exactly the same. I'm just going to structure and model this answer for you. We're only going to have to make a slight tweak because we're just identifying that magnesium loses 2 electrons and that we've got 2 iodine atoms that each gain an electron. So we've just got a slight variation, but I'm still going to follow exactly the same process, talk about it in the same order. So here's my first difference. Loses 2 electrons. Here's the second difference. A 2 plus ion. And whether you write 2 plus 2, or you write the words positive 2, it doesn't matter. They're all acceptable. And here's my third difference, that 2 iodine atoms. Just be careful with your word when you use the word atom and ion. You saw that I almost wrote down atom when in fact I'm an ion. Just be careful of that terminology, that's using that precise vocabulary. So 2 iodine atoms each gain 1 electron and become +1 ions. So in terms of marking points, it's 1 for identifying that magnesium loses. Second mark is for identifying that it loses 2 electrons. Third marking point is for identifying that iodine gains the electrons. And then our fourth marking point is the fact that we have used the word atom, electron and ion within our answer. Okay, hopefully you're absolutely smashing these. And then I've just put this one in. This is a higher level question. This is a level 3 question. So this would be expected to be found on a higher paper. And this time, unfortunately, we don't have a diagram to help us, but it does tell us what type of ions are formed. So we've got to be a little bit confident. We've got to understand that if magnesium is losing 2 electrons, then actually we're going to need 2 chlorines. So we're going to need 2 Cl minuses, because we've got to be confident and look at that and say, okay, well it's Mg2 plus, so it lost 2 electrons. If I've got a Cl minus, then I must have it must have gained an electron, so I must need 2 of those because the magnesium lost 2 electrons. Okay, but in terms of your structure of the answer, exactly the same process again. Talk about magnesium. What does it do? Does it lose or gain electrons? How many chlorines do we need? Do they lose or gain? And what type of ions do they become? Okay, so if you want to give yourself a bit of a challenge, hit pause on the video, have a go at this one, and then check back in and I'll just do the same again. I'll just model that answer for you, so you've had 4 different examples to take away with you. There we go, guys. There's our 4 marks in the bag. Okay, hope you found that session useful. Hope you now understand how table salt holds itself together. We've got those 2 opposite charges that attract, and they hold that compound together, forming us what we commonly know as table salt, which is sodium chloride. So you can now go away and annoy your family and friends by asking them to please pass the sodium chloride for your chips. Okay guys, I'll see you next time.